All right, let's talk about conditional probability. And look, this is not just some dry formula you have to memorize for an exam. Think of it as the core operating system for making smart, evidence-based decisions when everything's up in the air. This is how you get a genuine information advantage in economics, in business, and in finance. Okay, so let's put you in the hot seat for a second. A key market indicator, let's say an inflation number, just dropped, and it is totally not what anybody expected. What do? Do you sell off an entire asset class? Do you double down on your position? Or do you just sit on your hands and do nothing? Now, your gut might be screaming one thing, but a gut feeling is just a guess, right? Having a formal framework to update your strategy based on that new data, well, that's what separates a wild guess from a calculated professional move. And we're going to build that exact framework, starting right now. So here's our game plan. We'll start with this core idea of the information advantage. Then we'll get into the nitty-gritty of how you actually update your odds. From there, we'll apply it to making decisions with new data, scale it up for more complex scenarios, and even analyze strategic sequences. And finally, we'll see how it all comes together to give you a real, tangible, qualitative edge in your career. All right, let's jump right into section 1, the information advantage. I mean, the subtitle says it all. New data really is the most valuable asset in business. In any market, we are constantly working with incomplete information. We're in a fog of uncertainty. So your ability to correctly and quickly interpret new information as it hits, that's what creates a sustainable competitive edge. You know, every single forecast, every investment, every strategy you build, it all starts with an initial set of probabilities. What's the chance of a recession next quarter? What's the likelihood the startup actually hits its revenue goals? But these odds aren't static. They're not set in stone. The entire game changes the moment a new earnings report comes out, or a new regulation is passed, or a competitor makes a surprise move. Conditional probability is simply the language we use to adapt our strategy in real time. So for section 2, let's see how we can build this simple idea into a really powerful, formal framework. We've talked about the why, so now let's get into the how. We're going to start with a super intuitive example just to make sure we've got the foundation solid. Okay, imagine you roll 2 fair dice. Before the roll, you know there are 36 possible outcomes, right? But what if I give you a piece of new information? I lean over and tell you, hey, the first die, it landed on a 3. How does that change the probability that the total sum is 8? This is a perfect, simple analogy for how a new piece of economic data should force you to rethink your forecast. And just like that, our entire universe of possibilities collapses. That single condition, knowing the first die is a 3, it instantly eliminates 30 other outcomes. They're just gone, irrelevant. We are now operating in a new, much smaller world where the only possibilities left are these 6 right here. And here's the result. In our new, smaller world of 6 outcomes, only one of them, the 3-5, gets us the sum of 8 that we're looking for. So the probability, given our new information, is now 1 out of 6. We've just updated our odds. We went from a general 5 in 36 chance for a sum of 8 to a much more precise 1 in 6, all thanks to one new piece of data. And this brings us right to the formal definition. This little formula is the engine that powers this entire process. The probability of event A, given that event B has occurred, is the probability of both A and B happening divided by the probability of B happening in the first place. With our dice, it was the chance of rolling a 3-5 divided by the overall chance that the first die would be a 3. So, if you only take one thing away, it should be this. The crucial point is that we are formally and mathematically updating our beliefs, our probabilities, based on new evidence. This is not just a math exercise. It's a dynamic framework for reacting intelligently to a changing world. It is the absolute foundation of data-driven decision-making. Okay, on to section 3. Let's level up. We're moving on from dice and applying this framework to problems that look a lot more like real strategic business choices, like how to allocate your capital when you have imperfect information. So let me introduce you to Joe. He's lost his key. Based on his habits, he's got some initial beliefs, what we call prior probabilities. He thinks there's a 40% chance it's in his left pocket, 40% in his right, and a 20% chance it's somewhere else. This is a classic resource allocation problem. Where should he spend his limited search capital, his time, first? Well, based on these odds, either pocket is an equally rational first choice. But then he gets new information. He searches his left pocket, and it's empty. Now that failed search is actually incredibly valuable data. The 40% probability he had assigned to the left pocket is now 0. And that probability has to go somewhere, so it gets redistributed proportionally. All of a sudden, the chance the key is in his right pocket has jumped to almost 67%. His optimal search strategy has completely changed because of that new evidence. Here's another distinction that is absolutely vital for any analyst to understand: the difference between joint and conditional probability. Let's say Celine flips a coin to choose between chemistry and physics. The probability she gets an A in chemistry from the very beginning is a joint probability. Two things have to happen. She has to choose chemistry, and she has to get an A. The total chance is 1/3. But the conditional probability, the chance she gets an A, given that she's already in the chemistry class, is much higher. It's 2/3. For risk analysis, understanding this difference is everything. You have to evaluate the odds of success once you're already committed to a path. Now we're ready for section 4. And this is where we really start to scale these tools up. We're moving from these simple problems to modeling more complex, realistic business scenarios. Think quality control in a supply chain or segmenting a market for a product launch. So let's reframe this classic bridge problem as a quality control scenario. Imagine the 26 cards are a batch of components from a supplier. The 5 spades are defective units. You take a sample of 13 units to test. What's the probability your sample contains exactly 3 defects? This is a textbook case of sampling without replacement. Once a component is tested, it's not put back in the batch. And for this very specific situation, we need a special tool, the hypergeometric distribution. It's designed precisely to calculate these odds when each draw changes the probability for the next one. And here's another model. What's the probability that if you deal a 52-card deck into 4 equal piles, each pile gets exactly 1 ace? Now think of the 4 piles as 4 different market segments, or maybe 4 investment portfolios. The aces are a key resource, a high-value asset, and you want to ensure they're distributed evenly. This requires us to understand combinations and distributions, which brings us to what are called multinomial concepts. These are the tools we use when there are multiple possible outcomes for each trial, like a customer choosing between one of 4 brands, not just buying or not buying. Let's move to section 5. So far, we've mostly looked at updating beliefs at a single point in time. But business, finance, economics, they're all about sequences of events. A project roadmap, a supply chain, a trading strategy, these are multi-stage processes. We need a tool to analyze the probability of an entire sequence unfolding in a particular way. And that tool is the multiplication rule. This is one of the most powerful and practical ideas we'll cover. It says that the probability of a whole chain of events happening is just the probability of the first event, times the conditional probability of the second event, given the first one happened, times the conditional probability of the third, given the first 2 happened, and you just keep going. It's a chain of conditional probabilities that lets us map out and quantify entire strategic pathways. Here is a fantastic case study to tie all of this together. In the Champions League quarterfinals, you have 4 top-tier teams and 4 weaker ones. What's the probability that the random draw results in a balanced outcome, where no strong team has to eliminate another strong team early on? This is a perfect model for analyzing competitive dynamics, market structures, or even the principles of designing a fair system. What's so great about this problem is that we can solve it in 2 completely different ways, and that's a crucial skill for any analyst. The sequential approach on the left uses the multiplication rule we just discussed, calculating the probability at each step as teams are drawn one by one. The combinatorial approach on the right takes a bird's-eye view. It calculates the total number of ways to pair the teams, then figures out what fraction of those are the favorable pairings we're looking for. And they both lead to the exact same answer. As an analyst, when 2 different quantitative paths validate your conclusion, that gives you incredible confidence in your findings. And that brings us to our final section, your quantitative edge. Let's synthesize everything we've covered and talk about how this framework becomes a core element of your professional analytical toolkit. So, let's wrap with the key takeaways. First, conditional probability is just the formal language for updating your beliefs with new evidence. That's it. Second, those simple analogies, dice, cards, they're powerful tools for modeling complex business realities like market risk and quality control. Third, developing multiple analytical paths to solve a problem provides robust validation for any strategic conclusion you make. And finally, and this is absolutely critical for your future studies, mastering this is the essential foundation for more advanced topics you will encounter, like Bayes' theorem, and core concepts in machine learning and econometrics. So I'll leave you with a direct challenge, because this isn't just theory, it's a mindset.
What is one core belief you hold right now about a market trend, a particular stock, or a business strategy that you should probably reevaluate? What piece of new information could come along and fundamentally change your odds? The ability to consistently ask and answer that question, well, that's your new information advantage.